5.2, 3, and 4, part 3. So I left off with this one. The phone ran out of storage, so I had to start over. So the probability of square or circle would be the probability of a square plus the probability of a circle minus the probability of both. So the probability of a square is 24 out of 76. The probability of a circle is 16 out of 76. You can't get a circle and a square, so that would be 0, which is, oh, I've lost all my papers, 40 out of 76, which is 0.526. To get a blue or a yellow, so the probability of blue plus the probability of yellow minus the probability of both. Blue would be 25 out of 76. Yellow, 20 out of 76. You can't get a blue and a yellow, so that's 45 out of 76, which is 0.592. A red or a square, so the probability of red plus the probability of a square minus the probability of both. So red is 31 out of 76. Square is 24 out of 76. Red square would be 12 out of 31. Oh, that's a plus. And so that equals 43 out of 76, which is 0.566%. A blue or a triangle plus the probability of a triangle minus the probability of both. Probability of a blue is 25 out of 76. Probability of a triangle is 36. And the probability of a blue triangle is 9 out of 76. And that's 52 out of 76, which is 0.684. So dependent probabilities. Dependent probabilities is the probability of A given B is the probability of A assuming that B has already occurred. So explain in words what the following dependent probabilities. This is the probability of B knowing T has occurred. Probability of T knowing B has occurred. If you're trying to get red, what shape is best? A triangle shape would be the best because you have more red triangles. I'm not sure where that comes into play. Alright, so independent events are those whose outcomes do not affect one another. Alright, so if A and B are independent, then the probability of A and B, or it can be written as the probability of A comma B, which is the probability of A times B. If A and B are dependent, then it's the probability of A and B, or probability of A and B comma B, but it's the probability of A times the probability of B given A has already occurred. So the difference is the independent and whether it's dependent or independent. So independent. The probability that we're going to draw an ace and roll a 5. So the probability of an ace, you have 4 aces out of 52 cards, and the probability of rolling a 5 is 1 out of 6. So we'd multiply those two together. Draw an ace and a 5. So the probability, if the dependent would be the probability of the ace, which is 4 out of 52, and the probability of drawing an ace given that you've already drawn a 5. So that would be 4 out of 51. See, that's what makes it confusing, is this. This is rolling the die. This is drawing a card. And so you only have 51 cards if you've drawn one already. And you know that it's a 5. You still have the 4 aces, but you only have the 51 cards. So a quiz has 2 questions. One is true, false. The other 4 parts is multiple choice. Let C equal correct and W equal wrong. So the probability that you get a correct and a correct, it's one true, false, and the other is multiple choice. Well, the probability that you get a correct true, false is 1/2 times the probability that you get a correct multiple choice is 1/4. So that would be 1/8 or 12.5%. Okay, probability of a C times the probability of a wrong answer. So the probability of a correct answer is 1/2. The probability of a wrong answer is you have 3 wrong answers out of 4. So that would be 3/8 or 37.5%. The probability of a wrong, true, false, times the probability of a correct multiple choice would be 1/2 times the correct multiple choice is 1/4. So this is 1/8 or 12.5% again. The probability of a wrong and a wrong. One-half to get a wrong, true, false. 3/4 to get a wrong multiple choice. So that's 3/8 or 37.5%. So a bin is approved for shipment if no defects show up when 3 are randomly selected and tested. If 6 fuses in a bin of 80 are defective, then find if G equals good and D equals defective. If fuses are replaced in a bin after testing, then the probability of approval would have to be the probability of a good, good, good. And the probability of good times the probability of good times the probability of good would be, if there's 80 and 6 are defective, 74 would be good out of 80 times 74 out of 80 times 74 out of 80, which is 74 out of 80 to the 3rd power. And so this is an important word right here, that it's replaced. So if the fuses are not replaced in the bin after testing, then the probability of approval would have to be the probability of a good, good, good. But what would change is that the first one you have 74 out of 80, but now you only have 79 to choose from, and you've chosen a good one, so that would be 73 out of 79. And now you only have 78 to choose from, and you chose another good one, so now you only have 72 goods to choose from. So which procedure is more likely to find defective fuses? Well, let's see what our percentages are. So 74 divided by 80 raised to the third power is 79%, and 74 times 73 gives us 78 or 0.789. So if fuses are replaced, then the approval is 79% of the time. Which procedure is more likely to find defective fuses? And that would be the without replacement.